Welcome to the next session of the differential equation. In this session, we will discuss about the solution of the differential equations. We focus only the first order ODE in this part. We will focus only the first order ODE. See, what is actually a solution? That is a function y is equal to gx is a function y is equal to gx is called a solution of the first order ordinary differential equation in some open interval a less than x less than b. Maybe this is the finite open interval, definite open interval, maybe indefinite open intervals may be exist. The entire real line may be the domain of the function. That is also no problem. Okay. If g of x is defined, we say that g of x is the solution if g of x is defined and differentiable in this interval. And also is the equation becomes an identity. The actual differential equation remains it as an identity if we replace y and y dash with g and g dash of x. With g and g dash of x, g of x and g dash of x, we replace y dash y and y dash with g and g dash of x, even though if the equation remains as an identity, then we say that g of x is a solution of a differential equation on this open interval. As I said you before, the open interval may be definite or indefinite, that is doesn't matter based on the domain. We all know the solution is actually, we are discussing about the first order ordinary differential equation, and in this first order ordinary differential, because it is a ordinary differential equation, the functions are the consist only the single variable functions with one independent variable and one dependent variable. That is why the solution will be a curve in a plane. That is actually we call it as the curve in a xy plane, where x stands for the independent or domain part and y stands for the function part. So, we can say that the g of x will be a function or curve in a geometrically, graphically y is equal to g of x is a curve in a plane. Okay, that means simply we can say that the all functions defined on a particular interval, that is the solution of differential equation if it satisfies that differential equation. If it satisfies that differential equation. See, while moving to here, y dash is equal to 2y, or simply we can say that this is actually dy by dx is equal to 2y. See, we have instead of g of x, we have y is equal to e raised to 2x is there. See, y dash while differentiating this is dy by dx is equal to the derivative of e raised to 2x. Derivative of e raised to 2x is, we know, 2 e raised to 2x. So, 2 e raised to 2x is there. See, here y is equal to e raised to 2x. So, we can replace e raised to 2x as y. Therefore, dy by dx, dy by dx is equal to 2y. That is actually dy by dx is equal to 2y. That is simply we can say that y dash is equal to 2y. So, simply we can say that the function y is equal to e raised to 2x satisfies the differential equation. Therefore, we can say that y is equal to e raised to 2x, y is equal to e raised to 2x is a solution of differential equation y dash is equal to 2y. Say, my dear students, I would like to say check about is y is equal to c e raised to 2x. Y is equal to c e raised to 2x. Is it a solution? That is my next discussion. Of the same differential equation, the differential equation is y dash is equal to 2y. See, y dash is equal to 2y. We can find this is the y dash, that is dy by dx is the derivative of 2 into c e raised to 2x, okay, that is where c raised to 2x is actually y, therefore, this is equal to 2c e raised to 2x. Fine, instead of c e raised to 2x we can replace with y, therefore, y dash is equal to 2y. Fine, y is equal to c e raised to 2x is also solution of y dash is equal to 2y. So, what we can say here, we have c. I would like to say the c is an arbitrary constant. I would like to say c is the arbitrary constant. C is arbitrary constant. Here c is arbitrary constant. What is arbitrary constant? That is the constant which have a power of a variable, So, like variable is a constant like variable. So, which can choose different values for c. So, as because c is an arbitrary constant, they have a possibility for infinite possibility for c. So, what is the meaning? The differential equation y dash is equal to 2y may have more than one solutions. As according to this, we can say that it may have infinitely many solutions. So, we can say that this solution is called, I would like to say this solution as a general solution. So, what is actually the general solution? Is a solution if which consists of an arbitrary constants, which may provide infinite choice for the solution. So, what we did before, this is one of the solution, because instead of c, here we have the value, we can say that here we have the value, 1 is here, instead of that here we have the value 1, okay. So, the value of c is equal to 1, so that we can say that that is a particular value, so that we can say that this is a particular solution. This solution y is equal to e raised to 2x is a particular solution of a differential equation, y dash is equal to 2y. So, if the solution consists of an arbitrary constant, then such solutions are called general solution. If we give particular values for that arbitrary constant, then such solutions are called the particular solution of a differential equation. So, this is one of the solution. Also, we can just move to another example. In this example 2, I would like to say y is equal to sin x is a solution of y dash is equal to cos x. We can check y dash the dy by dx. So, while evaluating dy by dx here, derivative of sin x is the cos x. Derivative of sin x is cos x, so that y dash is equal to cos x satisfies. So, that is y dash is equal to cos x is here. So, find the y is equal to sin x. While differentiating, the curve y is equal to sin x will satisfy the differential equation y dash is equal to cos x. So, that we can say that y is equal to sin x is a solution of y dash is equal to cos x. Similarly, I would like to say y is equal to sin x plus c is another function. As because it is another function, I would like to differentiate again this one. So, I would like to put this as equation number 2, differentiate 2 with respect to x, fine. Okay, dy by dx equal to derivative of sin x is cos x, okay, and derivative of c, even if it is an arbitrary constant which have a power of a variable, which act like a variable even though that is a constant, therefore, derivative equal to 0. So, dy by dx equal to cos x is the y dash is equal to cos x. Therefore, we can say that sin x plus c is also, that is y is equal to sin x plus c is also a solution of y dash is equal to cos x. That is not only just a solution. See, the c is an arbitrary constant. So, this is the general solution, which is the general solution, of y dash is equal to cos x. So, that is the general solution of the y dash is equal to cos x. So, in this form there may exist many kinds of solutions are there. See, we can take another curve in the plane. I would like to consider and the curve as example 3 as x square plus y square minus 1 equal to 0. Okay. While seeing the curve, see, we have, while taking 1 to here, you may have this as x square plus y square is equal to 1. Okay. You may go back to your very early classes. From the 10th standard onwards, you understood about this curve. This is an equation of a circle. Centered at origin, with radius 1. That is a unit circle, radius 1. So, which is a unit circle. Fine. I would like to just differentiate this equation. So, just I put this as equation number 1. Differentiate with respect to x. See, instead of x square we have the derivative as 2x, and instead of y square we have 2y. Not only 2y, again we have to put a dy by dx if we differentiate y. Therefore, dy by dx, simply we can write this as y dash. Derivative of 1 is equal to 0. Okay. We have 2 is here, therefore we can say that, take this as 2 into x plus y dash is equal to 0. Okay, fine. We take the 2 to here to denominator. So, we will have x plus y dash is equal to 0. See, this is a differential equation because which involves the y dash is here, y dash is actually dy by dx. So, is a differential equation. This differential equation we generated from the curve x square plus y square is equal to 1, or x square plus y square minus 1 equal to 0. See, we can say that this equation of circle, the unit circle, is a solution of the differential equation x plus y dash is equal to 0. See, I would like to put instead of this, instead of 1 x square plus y square is equal to c square or c. Well, this is the circle centered at origin with a radius c, where c is the arbitrary constant. So, what we can say that this is also, while evaluating, this is also the solution of the differential equation. I just left this as an exercise for you all. Just differentiate. While differentiating this, this is equal to 2x is here. While differentiating y square, we will have 2y dash, and while differentiating c square, as because that is a constant, the value equal to 0. The same identity will get. So, that is why we can say that x square plus y square is equal to c square is a general solution of x plus y dash is equal to 0. So, what about this figure, x square plus y square equal to c square? You can have many circles centered at origin with radius. You can have circles centered at origin. Just we can write this as, you will have x axis is here, and we have x axis as well as y axis is here. you can draw the circle with the arbitrary constant. That means this is equal to, see, you can have is a circle which is centered at origin, and we can have many circles, the concentric circles. We may have the many concentric circles like this. This is another circle centered at origin with another radius, and you can draw other circles also, and similarly you can have infinitely many circles. You can have a very small circle inside, you can have a, you can draw the circles inside it. See, these are all circles, concentric circles. Inside a circle you can have infinitely many circles. So, if the thickly packed circles will be there, we will feel like a disc. Depends on the different values of C. They are all the solutions of the differential equation x plus y dash is equal to 0. Among that, this is the only a particular solution. So, while evaluating this one, I would like to say x square plus y square minus 1 equal to 0. We just started with this, we have the solution as x square plus, we just started x square plus, x square plus y square minus 1 equal to 0. That means we can represent this as a g of x y is equal to 0. This is the form of implicit form. This is the implicit form. This is the implicit form. So, that means the function is implicit function. Implicit function. So, they have one more choice, it is that maybe the solution can represent as implicit function, or otherwise sometimes may represent like a explicit function, as like this. As we done here, these are the explicit type of the functions. Maybe explicit type of function can be converted into implicit function also, as we done before. Okay. So, solution may exist either in implicit form or explicit form. See, I would like to just draw one more question as verify e raised to 2x is a solution of differential equation. E raised to 2x is a solution of differential equation y double dash minus 5y dash plus 6 equal to 0. See, while evaluating this differential equation, I just put it as equation number 1. While evaluating the differential equation, see, y dash is the second order derivative, and y double dash is the second order derivative, and y dash is the first order derivative. So, highest order derivative is the second order derivative. So, this is second order differential equation, second order ordinary differential equation. So, you have to check whether e raised to 2x is the solution. That is, just we have to check whether is it satisfies the differential equation or not. So, just I put y is equal to e raised to 2x. We just differentiate this as y dash is equal to 2 e raised to 2x, and we have to find y double dash is also. So, we have y double dash is equal to 2 into 2 4 e raised to 2x. See what will happen, apply in, put in 1. Put in 1. So, we have y double dash is equal to 4 e raised to 2x, 4 e raised to 2x minus 5 into y dash, 5 into 2 into e raised to 2x, therefore 10 e raised to 2x. Okay. And finally, here we have, instead of 6, we have 6y is equal to 0. So, we have 6 plus 6 into y e raised to 2x. See, what is actually 4 e raised to 2x plus 6 e raised to 2x, 10 e raised to 2x, 10 e raised to 2x, okay, minus 10 e raised to 2x equal to 0. Okay, fine, Fine. So, satisfies the equation. Therefore, we can say that this is the solution of, therefore, we can say that e raised to 2x. Therefore, we can say that e raised to 2x is solution of differential equation 1. Now, again I have one more question towards you. Is c e raised to 2x? Instead of e raised to 2x, I just put an arbitrary constant with this one e raised to 2x. So, I just asking to you as, is c e raised to 2x is solution of differential equation 1. That is differential equation 1 as y double dash minus 5y dash plus 6y equal to 0. Okay, fine. See, instead of y, I put this as c e raised to 2x. So, instead of c, I would like to just change as c1. We will use one more thing here, that is why I just change it as c1. Y is equal to c1 e raised to 2x. Again, y dash is equal to, we differentiate this one, therefore 2c1 e raised to 2x, and I would like to find y double dash is equal to, again we will differentiate, this is again, therefore we will have 4c e raised to 2x. Okay, put in 1, what will happens? This is equal to, we can say that this is the y is equal to, we will apply y double dash, that is 4c e raised to 2x, also for c1 e raised to 2x, sorry, here we have c1 is here, for c1 e raised to 2x, and similarly we will have minus 5 into 2 c1, 10 c1 e raised to 2x, plus again we have 6 into c1 e raised to 2x, that is y. As we done just before, we can say that for c1 e raised to 2x plus 6 c1 e raised to 2x is equal to, we have 10 c1 e raised to 2x. Similarly, here we have minus 10 c1 e raised to 2x, minus 10 c1 e raised to 2x. Okay, 10 c1 e raised to 2x minus 10 c1 e raised to 2x, simply we can say that that is equal to 0, satisfies 1. Therefore, c1 e raised to 2x is also a solution of this differential equation. Just before we mentioned as this one e raised to 2x, which is the solution. Now, we have c1 e raised to 2x, c1 is arbitrary constant. So, this is a part of general solution. Now, again I am asking one more question towards you, is that is c2 e raised to 3x. Okay, instead of the e raised to 3x, I would like to go to general solution, and c2 e raised to 3x is a solution of 1, which is actually this is equal to y double dash minus 5y dash plus 6y equal to 0. Fine. Say while evaluating y is equal to c2 e raised to 3x. Okay. Now, while evaluating this one, c2 e raised to 3x is there, and one more thing is that we have y dash is equal to, see, we have y dash is equal to 3c2 e raised to 3x, and again y double dash is equal to, again we have, this is the this is y double dash is equal to 3 into 3, 9c2 e raised to 3x. Okay, put in 1, while putting into 1, put in 1. So, we will have this is equal to y double dash is equal to 9c2 e raised to 3x, 9c2 e raised to 3x minus 5 into 3. Okay. Therefore, minus 5 into 3, that means 5 into 3, 15 c2 e raised to 3x, plus again we have finally we have 6y, 6 into c2 e raised to, e raised to 3x. Okay. 9c2 e raised to 3x plus 6c2 e raised to 3x, that is 15c2 e raised to 3x. So, this is equal to 15 c2 e raised to 3x and minus 15 c2 e raised to 3x. Okay, fine. This is equal to 0. So, satisfies this equation, fine, equal to 0. So, see the game. We have C2 before C1 e raised to 2x is a solution, e raised to 2x is a solution whose general solution may be C1 e raised to 2x is there. Now, we found C2 e raised to 3x is also satisfied, where C2 is another arbitrary constant, that is also satisfies the equation. Therefore, C2 e raised to 3x is also a solution. Now, see, I would like to ask one more question towards you, is that finally I will ask is y is equal to C1 e raised to 2x plus C1 e raised to 2x plus C2 e raised to 3x is solution of equation 1, solution of equation 1, that is y double dash minus 5y dash plus 6y is equal to 0. See, what about y dash? Y dash is equal to 2 C1 e raised to 2x plus 3 C2 e raised to 3x. What about y double dash? This is equal to y double dash is equal to 2 into 2 4 C1 e raised to 2x plus 9 C2 e raised to 3x. Put in 1. Okay. So, we will have y double dash, that is equal to 4 C1 e raised to 2x plus 9 C2 e raised to 3x is there. Again, we will have minus 5y dash is there. So, minus 5 into 2, 10 C1 e raised to 2x minus 5 into 3 plus that is minus 5, therefore, minus 15 C2 e raised to 3x is there. Finally, we have plus 6y is there, that is why plus 6 into C1 e raised to 2x plus 6 into C2 e raised to 3x. See, what is the miracle is that this is the 4 C1 e raised to 2x 4 C1 e raised to 2x plus 6 C1 e raised to 2x. Therefore, we will have 10 C1 e raised to 2x minus 10 C1 e raised to 2x. We have 10 C1 e raised to minus 10 C1 e raised to 2x and 4 C1 e raised to 2x and 6 C1 e raised to 2x is here. We have remaining 3 terms are here, that is the remaining 3 terms are 9 C2 e raised to 3x plus 6 C2 e raised to 3x. Therefore, this is equal to plus 15 C2 e raised to 3x minus 15 C2 e raised to 3x, okay, minus 15 C2 e raised to 3x. See, 10 C1 e raised to 2x minus 10 C1 e raised to 2x is 0, 15 C2 e raised to 3x minus 15 C2 e raised to 3x which is also equal to 0. So, this also will satisfy the equation. So, that we can say that the sum is a solution. So, simply I would like to say the equation differential equation 1 as a linear differential equation, second order linear differential equation. C1 e raised to 2x plus and C2 e raised to tx are the linear combination of the or sum of the two general solutions. So, this is also the general solution of the differential equation 1. Okay. So, if y1 and y2 are two solutions, their sum or their linear combination is again solution of a second order linear differential equation. See, there are many questions are available, many problems are available in our literature. You may go through all this, you can find out many examples, and I would like to give you an assignment. Verify verify y is equal to e raised to 2x and y is equal to e raised to minus 2x and e raised to minus 3x, and y is equal to e raised to c1 e raised to minus 2x plus c2 c1 e raised to c2 e raised to minus 3x are solutions of y double dash minus plus 5y dash plus 6y is equal to 0. Okay. Y double dash plus 5y dash plus 6y is equal to 0. Second one, verify y is equal to cos x is a solution of y dash is equal to minus sin x, or y dash plus sin x is equal to 0. Okay. You can find many questions from the literature. You may do the differential equation. While doing more differential equation, you will feel this is like a game. Okay. Thank you for your watching. Continue your watching. Thank you very much.